My name is Boris Banyas, and together with my partner Michal Teuger, we are owners and founders of a company called Hemp Seed Oil Europe Limited. Hemp Seed Oil Europe has been operating on the market for a few years already, and we specialized in a bulk and private label supply of hemp food ingredients. We operate in all Europe. Also, among us, we have our friends, distributors. We know quite a lot of people here, and over the course of the years, we have found that yes, there is a hemp food market already. It's getting developed. More and more people understand what hemp food is all about. But we understand that you always have to be at least half a step ahead of competition. I would really hate calling it a competition, because the hemp industry is so small that we all know everybody, and we are more of friends than competitors. But still, there has to be a progress and there has to be an innovation, and we are very proud that this year we are going to present to the market a really novelty. We understand that nobody else has yet introduced hemp seed derivatives like hemp oil or protein powders or flours made from the germinated seed. First of all, I would like to ask you if you know what germination or sprouting is about, because maybe we should clarify it. So, germination, or synonymous is sprouting, is basically when the seed starts to live. And of course, if you let it live, it starts to shoot the green part. This is what the germination is about. But we are not talking about shooting the green stem. We are still talking about very beginning of the germination, and we will now present what are the major benefits of the germinated seeds and what are the major biochemical changes in the structure of proteins, fats, and carbohydrates of the food, and also what are the new synthesis of new active ingredients in the hemp seed. Because first of all, we have to understand, and I hope everybody understands, that hemp is a functional food ingredient. So the title of the presentation is Changes of Fats in Germinating Hemp. This presentation has three parts. In the first one, we will talk about classification of food from the perspective of availability of the nutrients. In the second part, we will discuss properties of fats and their digestion. And in the last part, we will present our results, which we did so far. So, what are we eating and trying to digest? That's the elementary question. Probably not everybody knows that the greens surrounding us contain tremendous amount of omega oils. The dry matter of green grass, like wheat or barley, contains about 5% fat. However, this fat has around 65 to 70% ALA omega-3 fatty acid content. So the stupid animals are eating the green mass, while us, the clever people, are eating the concentrates, the grains that have no omega fatty acids. Most of our foods are made from the dormant seeds. These propagating units are not meant to feed us, but to save the transfer of genetic information to another generation. Plants have built up several protection systems to prevent their propagating units, and this protection can be physical or chemical. When we start to utilize the seed as nutrient, these protecting mechanisms are acting as anti-nutritive materials in our foods, which make them difficult to digest and utilize. Because these anti-nutritive materials are present also in the processed food, up to 80% of the nutrient content cannot be utilized by human or animal organisms. A large amount of the nutritional material produced by the agriculture is lost because of the improper understanding and processing of the foods. Now imagine how serious this situation gets with raising human population and ongoing climate change. Nutrients in the seeds are stored in a form of giant molecules in a highly condensed form. You can just imagine a zip file in a computer. And the basic goal of our digestion is to break down or open these molecules in order to make them utilizable for our organism and break down the several anti-nutritive materials. And this really demands a lot of energy that our body spends on trying to digest something not easily digestible. So what's the paradigm shift? This is our standpoint. We already know that there is a modern technology that can handle industrial scale germination to serve changing consumer habits. Germinating or sprouting seeds break down these anti-nutritive components. There is a new synthesis of vitamins and enzymes. Nutritional material is biochemically changed. So practically we are already eating pre-digested food. And functional ingredients are getting released, and now these materials are becoming almost 100% biologically available. So now comes the hard part. We will now talk about fat and fat digestion. There is lots of chemistry or nutrition science behind this. I hope I will not bore you too much, but please bear with me. So what is fat? Most of the food fat comes in the form of a triglyceride, which we call TAG, triglyceride, which is formed by a molecule of a glycerin to which are bonded 3 molecules of fatty acids. They can be different fatty acids, saturated, monounsaturated, polyunsaturated. So we will also use this symbol in the presentation. So here we see a base of the glycerin and 1, 2, 3 individual fatty acids. Fatty acids are a family of molecules classified as lipid macronutrients. One of their main roles is the production of energy in the form of synthesis of adenosine triphosphate, or ATP. The people who are in the sports segment or sport nutrition of the bodybuilders, they probably should all know what ATP synthesis is all about. So as I said, depending on the fat source, TAGs can be either saturated or unsaturated, depending on which fatty acids are bonded on the glycerin. So how are the fats digested? Our body uses an enzyme called lipase and a bile to break down fat molecules into individual fatty acids and monoglycerides in order to absorb them. So this is what happens in our stomach, or not in our stomach, in our duodenum, which is a part between the stomach and the small intestine. So the lipase enzyme comes in together with the bile, and they break down the TAG into fatty acids and so-called monoglycerol. This process is called hydrolysis of fats, and as I said, happens in our duodenum. During the germination, a similar process is activated. We call this process partial hydrolysis. So 1 or 2 fatty acids are released from the glycerin molecule, and we have 2 different fats which are being produced in the germinated seed. One is composed of diglycerides or monoglycerides. So here we can see that, for example, in this molecule, it's a DAG, deacylglycerol. It's called 1,3 because the middle fatty acid is already missing. And by the germination, we have demonstrated that we can convert up to 25% of fat into the DAG form. So again, the triglycerides are partially hydrolyzed to diglycerides or even monoglycerides when there is only one fatty acid. So what is the difference between DAG and DAG fat? Conventional cooking oils are mostly triglyceride fats with a small amount of diglyceride, because every seed is not, the seed is never completely dead, right? So even during the harvest, there is the moisture, it actually wakes up, there is big issues about rancidity in the oil industry, so there is always one portion, small portion of the fat in the oily seed which has been already partially hydrolyzed. So the triglycerides are hydrophilic. So everybody knows that it's very hard to mix oil with water, right? They just don't get along. But the DAGs are hydrophilic. They can bond water chemically. This difference is very important from the perspective of fat transfer in our body and industrial applications. As we said, that when we said that we can convert 25% of the fat in the seed to a DAG, out of this portion, 70% is in the form called 1,3-diacylglycerol. So here we have a regular oil, diacylglycerol in 1,2 form, and diacylglycerol in 1,3 form, depending on which fatty acid got released. So the shape of these molecules is treated differently in the digestive system. So while the DAGs and 1,2-DAGs are mainly used as a fat storage, 1,3-DAG can act as an immediate source of synthesis of DHA, we'll talk about it, and energy. We'll talk about it in the end of the presentation. So, now comes the most interesting part. So when we consume oils, it doesn't matter whether it's a regular cooking oil or cold-pressed hemp oil or oil pressed from the germinating seed. In the duodenum, everything happens the same in the duodenum. So lipase comes in and breaks down all different glycerols in the same way. So there is always free fatty acids and a monoglycerol, so the glycerin molecule with one fatty acid. So this is the same, but the small intestine rebuilds the DAG fats and 1 and 2 DAG fats and binds them back into fat packets. So as our food progresses to the small intestines, these two are rebuilt. And these fat packets are transferred by the lymphatic channels in our intestine, and they are transferred into our adipose tissues. So usually a lot of fat food makes you fat, right? You gain your weight. So DAG and 1,2-DAG fats are transferred by the lymphatic channels. But due to the shape of 1,2